Hi, today we're looking at Functional Skills Maths Level 1. This is the Open Awards exam board. We got the first sample assessment and we're going to start with the non-calculator section. Task 1. We've got question 1 here. We've got a diagram. It's not drawn to scale. We've got some measurements along some of the sides of the shape. And here we've got the actual question. Calculate the perimeter of the shape. Show your calculations and or workings out here. Right, so what I'm going to do to start with this is I'm going to make sure that I've got the measurements for all of the sides around my shape. So we've got 7.4, 12.6, 11.4, 6.4, 4 and 6.2 up there. Right, so we've got all of those. All we need to do is to add them together. So I'm going to mark here so I know where I'm starting. So we're going to have 7.4, 12.6, 11.4, we've got 6.4. Note I'm lining up all of the units, all the tens, and all of the tenths. So 6.4, then we've got 4, and finally we've got 6.2. Now, so I've got something to add up for the 4. I'm going to put a 0.0 in there. Okay, we want to add all of these together. Well, 4 plus 6 is 10, plus 4 is 14, plus another 4 is 18, plus 2 is 20. So 0 and carry the 2. Then we've got 7 plus 2 is 9, plus 1 is 10, plus 6 is 16, plus 4 is 20, plus 6 is 26, plus 2 gives us 28. So put the 8, carry the 2, and we can put the decimal point there as well. Now we've just got 1 plus 1 is 2, plus the 2 we've carried, we've got 48. So we've got a total of 48, and that is 48 meters. Question 2. Calculate 17 squared. Well, 17 squared, that's 17 times 17. So I'm going to show 2 ways that we could do that. We could do it as a column, 17 times 17 like this. I would say 7 times 7 is 49. 9 carry the 4. And then 7 times 1, or 1 times 7 is 7, plus the 4 is 11. Then we move on to the tens. So we can put a 0 for the units. So 1 times 7 is 7, 1 times 1 is 1. And then we can add these together. 9 plus 0 is 9, 1 plus 7 is 8, and 1 plus 1 is 2. So we've got 289. Now, multiplying a 2-digit by a 2-digit number isn't always that straightforward. So if we wanted to do a different way, we can say, well, 17 times 17, we can say, well, that's the same as 10 lots of 17 plus an extra 7 lots of 17. Well, 10 times 17 is nice and easy because we just put a 0 on the end. And for the 7 times 17, well, multiplying by a 1-digit number is always a bit more straightforward. So if we do 7 times 17, we get the 7 times 7 is 49. 1 times 7 is 7, plus the 4, 119. So we still end up with the same 2 numbers to add together. So we're still going to get our 289. But it might just make it bit easier because you're not having to multiply 2-digit by a 2-digit. So either one of these will be absolutely fine and get you full marks, or the full 1 mark. Question 3. There is a ratio of 6:1 red marbles to white marbles. There are 42 red marbles in total. How many white marbles are there? Show your calculations and or workings out here. So I'm going to quickly draw a ratio table. And we've got the ratio of red to white. So I'm also going to I'm going to do a total column. And we've got 6 red for every 1 white. So if that's all we had, there would be a total of 7 marbles. Now they're telling us that we've got 42 red marbles in total. Although they say total, it's not the total of red and white, it's the total red marbles. So I need to put the 42 down here. If I put the 42 over here, I'm going to get a different answer. So putting it in the red column, because it's to do with the red marbles. Okay, so we want to know, how are we getting from this 6 up to this 42 in terms of multiplication? Well, we can go through our 6 times table. So 6, 12, 18, 24, 30, 36, 42. So that's 7 times. So multiplying that by 7. So it means we need to do the same with this. So 1 times 7. So that means there's 7 white marbles in total. And for the total, well, we can multiply it by 7. 7, 7. So 7, 14, 21, 28, 35, 42, 49. Or we could have said, well, 42 plus 7 gives us 49. Okay, but actually all they're asking for is how many white marbles are there. So that's the answer we're after, just a 7. Question 4. Calculate 14.73 plus 18.49. Show your calculations and or workings out here. Right, so I'm going to write my 14.73 above my 18.49. And again, I'm making sure everything is lined up. Tens, units, tenths, hundredths. And we always start adding up from the far right. So 3 plus 9, or 9 plus 3 is going to give us 12. 2 carry the 1. 7 plus 4 is 11. Plus the 1 is 12 again. Carry the 1. We need to bring down our decimal point. 4 plus 8 is 12 again. Add 1 takes us up to 13. And 1 plus 1 plus 1 is 3. So we've got an answer of 33.22. Question 5. Calculate 46.8 divided by 100. Yeah, 46.8. Well, if we're dividing it by 100, write that here. We're dividing it, so we're making it smaller. And when we've got a 1 and some zeros, all we're doing is moving the decimal point. We're not going to change the digits, just where the decimal point goes, or maybe if we've got some extra zeros. We're dividing, so that means we're going to be making the number smaller. So that means the decimal point is going to move to the left to make it smaller. And how many places to the left? Well, we've got 2 zeros, so it's going to move 2 places to the left. So if if the decimal point's there, we need to add a 0 in front of it. So in other words, we end up with 0.468. Okay. Actually, it's been chopped off, but I can write that this is question 6. Just been chopped off the paper. Janice wants to put border strips around 3 sides of her square lawn. The length of one side of the lawn is 14 metres. I can show what these border strips look like. To calculate the number of strips she needs, Janice follows this rule. And the number of border strips is equal to the total length in metres divided by 3 times 2. And we're told that each border strip costs £9.89. Show an estimate of the cost of the required number of border strips. Show your calculations and our workings out here. Right, well, let's go back to this bit. So you've got a square lawn, and she wants to put strips around 3 sides of it. So I'm just going to draw 3 sides of this lawn. And one side is 14 metres. Well, if it's square, this side must also be 14, and so must that side. Okay. Now, we have been asked to show an estimate. Well, we've got sort of nice-ish numbers here, apart from the money. Each border strip costs £9.89. So the estimating I'm going to do is I'm going to say, well, that's approximately equal to £10. So that's my estimating. But I'm still going to need to use this formula. That's per strip. The number of strips we need is, and the first thing we need is the total length in metres. Well, it's going to be 14 plus 14 plus 14. Or we can say 14 times 3. 4 times 3 or 3 times 4. 3 fours, you've got 4, 8, 12. 1 times 3 is 3 plus 1 is 4. So this box, we're going to have the total length in metres, which is 42. We then need to divide that by 3. Well, we can do 42 divided by 3. 3 goes into 4 once with one remainder. 3 goes into 12 4 times. But actually, you could have just seen, well, we multiplied by 3 to get 42. So if we're now dividing by 3, we're going to get back to the 14 we started with anyway. Okay, so we end up with 14. And then we're going to multiply that by 2. Well, 14 times 2. 2 times 4 is 8. 2 times 1 is 2. Okay, so we're going to need 28 strips. 28 strips, each of them cost £10. So 28 times 10, we can just put the 0 on the end. It's going to be £280. So this is still question 6, but it's part B. Janice wants to paint the fence panels in her garden. Each fence panel needs approximately 300 millilitres of paint. Oh, there's my protractor. She buys 2 tins of paint. Each tin contains 1.5 litres of paint. How many fence panels can she paint before she runs out? Okay, so each fence panel needs approximately 300 millilitres. So, and we know that she buys 2 tins of paint. Each tin contains 1.5 litres. Well, if we do 1.5 times 2, that's going to tell us how much paint she's got in total. 2 times 5 is 10. Put decimal point. 2 times 1 is 2, add the 1 is 3. So we've got 3 litres of paint. Now, here we've got millilitres instead of litres. So, well, I know that there's 1,000 millilitres in 1 litre. So in 3 litres, there's going to be 3,000 millilitres. And we want to know how many 300 millilitres fit in 3,000 millilitres. So in other words, 3,000 divided by 300. Well, we can cancel our zeros here. 1 with 1, another with another. So we end up with 30 divided by 3. And if we do that using the bus stop method, 3 goes into 3 once, 3 into 0 goes 0 times. So it's going to be 10 fence panels. And we can easily check that because we can say, well, if there's 10 of them and each one needs 300 millilitres, well, we just put the 0 on the end, which gets us back to 3,000 millilitres, which is equal to 3 litres. So that's like a little check for us. Part C. Janice wants to buy a table to put in her patio area. She draws the diagram of her patio to show the size of table she wants. What are the actual measurements of the table Janice wants? Right, so we've got a scale here. It says that one box is equal to 20 centimetres times 20 centimetres. Well, along here, how many boxes have we got? We've got 1, 2, 3, 4, 5, and that looks like half to me. So 5.5 boxes. What about the length of the table? We can just about fit that all in. I'm going to use my ruler. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we've got 11 boxes down that way. Okay. So we've got to use our scale now. So we had 5.5 boxes. So we want 5.5 times 20. Well, I'm going to ignore the decimal point, and I'm also going to ignore the 0 from the 20. So I'm just going to do 55 times 2. Okay, it might seem a bit strange. Let's write up here what we actually want, 5.5 times 20. But I'm ignoring the decimal point, ignoring the 0. So we can say 2 times 5 is 10. 2 times 5 again is 10. Add the 1 is 11. Now, this is where we need to say, right, well, it wasn't times 2, it was times 20. So we put a 0 in there. And actually, it wasn't 55, it was 5.5. So we need to put a decimal point in. So we end up with 110 centimetres. Now we need to do something similar down here. This time we've got, so that's for up here. For the 11 boxes, well, it's going to be 11. Again, times 20, so we want 11 times 20, but I'm going to do 11 times 2. Again, I'm just going to ignore the 0 and put it in afterwards. 2 times 1 is 2. 2 times 1 is 2. Add the 0 on. We've got 220 centimetres. We've got no decimal places this time, so we just keep it like that. So the actual measurements of the table Janice wants are 110 centimetres by 220 centimetres. And in fact, we've got a box here to put our answer. Question 7. Janice wants to buy new carpet for her bedroom. The bedroom is rectangular and has a floor area of 30 metres squared. Complete the table below to show the dimensions of her bedroom. Right, it's a rectangle. We've got the width is 4 metres and the length, well, question mark, we don't know. But we do know that the area of a rectangle is the length times the width. And they've told us that the area is 30. The length, we don't know, but the width we know is 4. So something times 4 gives us 30. Or if we do the opposite, the inverse operation, we're saying, well, 30 divided by 4 is going to give us our missing length. So let's do a bus stop method. 30, and we're dividing that by 4. Well, how many times does 4 go into 30? Well, we've got 4, 8, 12, 16, 20, 24, 28. 32 would be too many, so we're going to stop at 7, which was 28. But 29, 30, we've got 2 left over. So what we can do is 0.0, so we've got somewhere to carry over the 2. Now we need to put a decimal point up here as well. Keep it in line. How many times does 4 go into 20? 4, 8, 12, 16, 20. That's 5 times. So the length must be 7.5 meters. And that's the end of the non-calculator section. So onto the calculator section now. And with this paper, this exam board, they continue the question numbers. So rather than starting from 1 again, it's question 8 overall. So we've got a bag contains 6 red balls, 6 yellow balls, and 6 blue balls. Express as a fraction the probability of picking out a blue ball. Well, let's start with the denominator. That's going to be the total. Well, we've got 6 plus 6 plus 6, or 3 lots of 6. So it's going to be 18 balls in total. We're only interested in a blue ball, so it's going to be 6 out of 18. Okay, and we can leave it like that. We could simplify it, because we could say, well, actually 6 goes into 18. So we can say 6 goes into 6 once, and 6 goes into 18 3 times. But they've not asked us to express it in its simplest terms, so we could just leave it like that. Question 9. Convert 5/8 or 5/8 to a percentage. Show your calculations and or workings out here. Right. So 5/8, to make it a percentage, we multiply it by 100. And 5/8 means 5 divided by 8 times it by 100. And we get 62.5%. Question 10. Calculate 2.5 divided by 0.375. Give your answer to 2 decimal places. Well, remember we've got a calculator here, so 2.5 divided by 0.375. We get 6.66666. They want 2 decimal places. Well, that would be 2 decimal places, 6 and 6, but we have to look to the next digit. It's more than 5, so we're going to have to round that to 6.67, because that's more than 5. This one gets increased by 1. And we can write that in here. Question 11. Jared owns a bakery. He receives an order for party cakes to serve 72 people. He has this list of ingredients. So we've got party cake ingredients, and this serves 12 people. So we've got 400 grams of flour, 400 grams of butter, 375 grams of sugar, and 6 eggs. Jared has 2 3/4 kilograms of flour. How much flour will Jared have left over if he bakes enough cakes for everyone at the party? Give the units in your answer. Show your calculations and or workings out here. Right, so we're only interested in flour in this question, so we can ignore everything else. This is the flour. Right, 2 ways of doing it. Now you might notice that 12 is a factor of 72. So you could say, well, 72 divided by 12 is 6. So basically we need to multiply this by 6 to find out how much flour we need in total. Now, if you don't see that, that's absolutely fine. It doesn't matter. Instead, what you can say is, well, if I've got 400 grams for 12 people, if I divide it by 12, that's how much flour I need for one person. And if I want 72, well, I multiply it by 72. The only thing is then we need to do a little bit of rounding. So flour for 72 people. Well, it's going to be 2399.99. So we're going to round this up, so we can call this 2,400 grams. Jared has 2 3/4 kilogram of flour. Well, 3/4, what's a kilogram? Well, we know there's 1,000 grams in 1 kilogram. So 3/4 of a kilogram is going to be 1,000 times 3/4, 750 grams. Okay. So 2 3/4 of a kilogram of flour is going to be 2,000 for the 2 kilograms, 750 grams. So this is how much flour he's got. This is how much we need. So how much will he have left over? Well, it's going to be the 2,750 minus the 2,400 that he uses. Which gives us 350, and that's grams. Jared wants to bake 6 loaves of bread. A loaf of bread takes 7 minutes to prepare. Jared will bake all the loaves at the same time. The loaves will take 45 minutes to bake. He allows 10 minutes for them to cool down. What is the latest time that Jared should start preparing his first loaf of bread so that all the loaves are cooled by 6:15 a.m.? Okay. Right, he wants to bake 6 loaves. A loaf of bread takes 7 minutes to prepare, but then they're all going to bake at the same time. Okay, but the preparing is per loaf. So we're going to need 6 times 7. Which is 42 minutes. And that's to prepare. Then we're going to need an extra 45 minutes to bake and an extra 10 minutes to cool down. So we've still got the 42, add on the 45, add on the 10, and we've got 97 minutes in total. Okay. Now we're starting at 6:15 a.m. We need to take off 97 minutes. Right, now this can get a little bit messy. So what we can say is, well, why don't we just try and go back in small chunks? If we want to go back to 6 o'clock, we would need to take off 15 minutes. Well, if we do 97 minus 15, that means we've still got 82 minutes to take off of here. Okay. But again, we know there's only 60 minutes in an hour. So if we want to go back to 5 o'clock, well, we're going to have to do our 82 and take off 60 minutes. That means we've still got 22 minutes to take off at this time. Right, so we want 22 minutes before 5 o'clock. Well, it's going to have to start with a 4 o'clock before 5 o'clock because we've got no minutes left. And there's 60 minutes in an hour. So if we start with the full 60, so take away our 22, that leaves us with 38. So we're going to have to start at 4:38 a.m. And apologies if you couldn't see these bits because it was off the screen. So I'll just quickly run through that again. We know that we're starting at 6:15 a.m. We need to take off 97 minutes in total, but we're doing it in chunks. So we're taking off the 15 minutes to take us back to 6 o'clock, which means we're left with 82 minutes. Then we take off a whole hour, which means we've still got 22 minutes to take off from 5 o'clock. If we take 22 minutes off of 5 o'clock, that's like saying 60 minus 22, which brings us back to 4:38 a.m. Okay, part C. Jared needs to buy decorations for a celebration cake. He sees this price list at his local trade store. So items. So we've got candles are 13p each. Icing is £1.40 per packet. And sugar alphabet letters are 56p each. And there's a 20% discount if you use your trade card. Jared will use his trade card. Good, so we get 20% off. He buys 20 candles, 2 packs of icing, and 15 letters to make the word congratulations. How much money will Jared spend on the decorations using his trade card? Okay, so candles 13p and we need 20 of those. So I could do 13p times 20, but remember it was 13p or 13 pence. So to turn it into pounds, I'm going to divide it by 100. So it's going to be £2.60. Or what you could have done is the 13p you could write as 0.13, then multiply it by 20, you get £2.60 or £2.6. Icing, he needs 2 packets. So £1.40 times 2 is £2.80. And the sugar alphabet letters, 56p each, he wants 15 of them. So again, I can do this as 0.56 times 15, which gives me £8.40. Or you could have done 56 times 15, but then you just got to remember that's in pence, not pounds. So it's still going to give us the £8.40. Okay, so we then add these all together. So it's £2.60 plus £2.80 plus £8.40 gives us £13.80. But remember, we get our 20% discount. So we can do 20 out of 100 times £13.80. Which gives us £2.76. That's the discount, so we can take that off. So we can say £13.80 minus £2.76 leaves us a cost of £11.04. Part D. Use approximation to check the amount of the trade discount. Show your calculations and or workings out here. Okay, so what we had was we had £13.80. Well, we can say, well, £13.80, that's approximately equal to £14. Because it says approximation, okay? And we want 20%. Well, 10%, we divide by 10, we're just going to move the decimal point in here. So 10% would be £1.40. 20% is going to be double that. So it's going to be £1.40 plus another £1.40. Or you could think £1.40 times 2. So £1.40 times 2 is £2.80. Which is very close to the £2.76 discount that we calculated. Or what we could say instead is, well, the £13.80 minus the £2.80 this is probably better, is £11. And then we can say, well, £11, that definitely is approximately equal to £11.04. So that's fine. So you could do it here, but as I say, I'm thinking about it now, I wouldn't do that. I would then put it in here and compare it with the £11.04 instead. Both ways would work, but I think this is just a little bit nicer. Question 12. Write 190,493 in numbers. Right, 190,000. So 190,000. 493. 493. Question 13. The table below shows interest rates from 5 different banks. Which bank offers the highest interest rate? Well, it's going to be the biggest number. But what we can do is if we want to compare them, we can write one on top of the other. This is a nice way to compare. Then you've got a bit more like with like. Although if you do write them on top of each other, the first thing you might notice is, well, some have got 2 decimal places and some have got 3. Well, to give them all the same number of decimal places, let's fill in these empty bits with zeros. And because the 4s are all the same, we can just compare the decimal places. So we've got 720, 70, 726, 672, 760. Which is the biggest number of these? Well, it's not this one because it starts with a 0. It's not that because it starts with a 6. So 726 is bigger. 760 is even bigger than that. So it's going to be this one here, which is Bank E. And note, they're not saying what is the highest interest rate, they're saying which bank. So Bank E is the answer. Question 14. The table below shows the scores of 16 students in an exam. Complete the table below to show frequency. Okay, so how many people got a score of between 0 and 9? I can't see any of them. So 0 for that. How many got a score between 10 and 19? Well, there's 1. There's 2. How many got a score between, or a number of marks between 20 and 29? 1, 2, 3, 4. What about between 30 and 39? 1, 2, 3, 4, 5, 6. And how many between 40 and 49? 1, 2, 3, 4. And we should have used up all of them. Yet they're all crossed off. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And let's add these all up. We should have 16 here as well. 2 plus 4 plus 6 plus 4. 16, so that looks good to me. Question 15. Ryan is a member of a 5-a-side football team. The table below shows the goal difference for Ryan's team over the last 4 football matches. Goal difference is the number of goals for minus the number of goals against. Complete the table below to show the missing values. Okay, match 1, goals for. So that's like goals they scored. So they scored 2 goals. The goal difference was -1. Well, that means that the other team must have scored 1 more goal than them. Yes, if it's minus, it means the other team scored more. If it's positive, then Ryan's team scored more. So the other team scored 1 more than them. So it must be 3. The goal difference is 0. That means that both teams scored exactly the same. So we can put a 3 in there. Match 3, goal difference of -3. So again, the other team must have scored 3 more than Ryan's team. So 1 plus 3 gives us 4. So we can check it because we can say 2 minus 3 is -1. 3 minus 3 is 0. 1 minus 4 is -3. Well, what about if we do 1 minus 3? So they scored 1. The other team scored 3. That gives us a goal difference of -2. And what about the totals? Well, we've got 2 plus 3 plus 1 plus 1. So Ryan's team scored 7 in total. But the other teams scored 3 plus 3 plus 4 plus 3, scored 13 against them. And for the total goal difference, we can either add these up Or we can say, well, 7 minus 13 is minus 6. Or you can check. So 1 minus plus 0 plus 3 minus plus 2 minus gives minus 6. So it's a little check there as well. Okay, B. Ryan's team are playing a match on Saturday. The table below shows the predicted chance of rainfall on a scale of 0 to 1 from Monday to Saturday. Okay, so on Monday, the predicted chance of rainfall is 0.4, Tuesday it's 0.5, Thursday, no chance at all, okay, and so on. Ryan thinks it's unlikely to rain on Saturday. Is Ryan correct? Explain why you think this. Okay, well, if it's a scale from 0 to 1, well, halfway or even chance would be in the middle. So in other words, it would be 0 plus 1, all of that divided by 2. Or just more simply than that, well, halfway between 0 and 1 is going to be 0.5. Now 0.88 is more than 0.5, more than an even chance. So he thinks it's unlikely to rain. No, I think it's quite likely to rain. So is Ryan correct? No. Okay. So we can put likely to rain. Part C. The players in Ryan's team warm up before the charity match by running at least 1 kilometre around the edge of the pitch. How many full laps of the pitch will they need to run? Well, if it's 36 metres along the bottom, it's also going to be 36 metres up here. And if it's 18 metres down that way, it's also going to be 18 metres here. So let's work out the full perimeter. So we've got 36 plus another 36 plus 18 plus another 18. Which gives us 108 metres. Well, I know that 1 kilometre is 1,000 metres. So how many laps does he need to get up to 1,000 metres? Well, we can say 1,000 divided by 108. That gives us 9.259 laps. But it says how many full laps? Well, you might think, oh, we round it down to 9. But if he only runs, or if they only run 9 laps, 9 times 108, that's not going to be enough. So they're going to have to run 10 laps. They're going to have to go up to the next whole number. Part D. Ryan's team sold 380 tickets for the charity football match. 35% of the tickets were sold for children, and 20% of the tickets were sold for senior citizens. The rest of the tickets were sold at full price for adults. Ryan thinks that 176 tickets were sold at full price for adults. Is Ryan correct? Okay, show your calculations and or workings out here. Well, 35% for children and 20% for senior citizens. So in total, that's 55%. So how many were left? Well, 100 minus 55 is 45%. So 45% of the tickets were left. We want to know what 45% or 45 out of 100 of the full allocation is. So 45 out of 100 times 380 gives us 171 tickets, which is not equal to 176. So is Ryan correct? No, he's not. Part E. Ryan has collected £3,697.40 from the 380 ticket sales. The football club will donate £2.94 from each ticket to charity. How much money will be left after the donation? Show your calculations and or workings out here. Right, so they're going to donate £2.94 for 380 tickets. That's a total of £1,117.2, but that's 20 because it's pounds and pence. That's how much they donate. So how much is left? Well, it's going to be the starting £3,697.40 minus this donation, which leaves £2,580.20. Question 16. The table below shows sales of laptops over a 6-month period. So at January there were 28 sold, February 144, and so on for the other months. Draw a bar chart to show the sales of laptops over the 6-month period. Okay, well I'm going to draw a vertical bar chart. You can do it horizontal if you want. Normally people tend to do them vertically, but that doesn't mean you can't do it horizontally, but it just might mean that the paper, if you notice, it's sort of longer than it is wide, this grid here. So it's probably set up better for a vertical one. So I would stick with that unless you really don't like doing vertical bar charts. So we've got 6 months. So I'm going to start down here and I'm going to do 1, 2, 3, 4, 5, 6. So this will be my months along the bottom. Jan, Feb, March, April, May and June. Then we're going to work out the scale going up the side. Well, what's the biggest number? Because we need to go at least as high as the biggest number. 144, anything bigger than that? Yeah, 172 is the biggest one. So we've got to work out what we go up in. If we went up in tens, 10, 20, 30, 40, 50, 60, 70, 80, 90. No, we're going to go off the page. What about if we went up in 20s instead? So 20, 40, 60, 80, 100, 120, 140, 160, 180. Yeah, that's higher than 172. So I'll put that one in. So let's start at the bottom and check. It's always good to check these before you write anything definite in. So 20, 40, 60, 80. And in the exam, you do this in pencil, so you do have the chance to correct it if you make a mistake. These questions aren't always too difficult, but they can be quite time-consuming because of all the checking and rechecking you need to do. Right, so for January, 28 laptops were sold. So 20's down here. Halfway would be 30, halfway between 20 and 40. So each of these little boxes must be equal to 2. So in other words, if you think between 20, or let's look at the bottom, between 0 and 20, it's 20, but we've only got 10 boxes. So 20 divided by 10 means each box must be worth 2. So if we want 28, we've got 20, we're going to go 22, 24, 26, 28. So I'm going to draw my first bar there. Now for the next month, February, we've got 144. So we'll start at 140. And remember, we go up in 2s again, so 142, 144. For March, we've got 82. So where's March? Here's March. 80. 82 is going to be this one. April, we've got 126. 120 there, it's 122, 124, 126. I'm just doing the top lines at the moment. Now you might find it easier to draw, in fact I will do it, the vertical lines in. Let's draw the axes on the graph as well. Let's go up. So I usually do the bars all at the end to save time, but I think it's probably helpful to see what we're doing. So we've got our first bar here, our second bar for February. We're drawing in now. We're going to have March as well. April. For May, we've got 94. So where's 94 going to be? Well, here's May. Here's 80. If that's 190, would be in the middle. So 92, 94. And for June, we've got the big one, 172. So 160's here, 170 would be there, 172, be one up. Okay, so we've drawn the bar graph. We've got the label here and the months. We haven't got a label over here yet. This is sales of laptops. Need to make sure that this is in. And we want some sort of title, so we can just put laptop sales. Just need to describe what it's showing. Question 17. Devinda makes jewellery that she sells to local markets. She wants to buy some small boxes with lids, like the picture below, to put necklaces in. She receives a selection of boxes to choose from. The net diagram of each box is shown below. Okay, so we've got this box here. So this looks like the base with the sides, and then this is probably the lid that flaps over. Or we've got this one that looks like it's a bigger box, not as shallow as this one here. Okay, so we've got those two to choose from. Let's get the actual question. Ah, no, we've got four more. So we've got net A, net B, net C, and net D. And we're told, which net diagram best represents the box shown in the picture? Explain the reason. Explain the reason for your choice of net in the box below. So this is the picture. Right, well, let's think of it. Let's almost try and draw a net from this and then see which of the pictures looks like it. Well, we're going to start off. We've got a rectangle for a base. Okay, I'm deliberately not using a ruler. You can use it if you want, but it's supposed to be a sketch. I'm not trying to be super accurate. And then off this base, we've got a side piece here and another side piece down here. Then we've got this front piece, which you can imagine will drop down like that, and this piece up here. Because remember, a net is a 2D representation of a 3D shape. And then we've got the lid, which is going to be another rectangle up the top here. Okay, so this is what we want. We want something that looks like that. Well, straight away I'm thinking, A looks quite similar. The only difference with that is that I drew my lid on the top and they've got theirs down at the bottom, but it looks very similar. B definitely doesn't look right because we've got sort of the same, it's going to be a cube, isn't it, pretty much? The height are the same. We want these narrow pieces for the sides and the front. So I'm going to cross out B, definitely not B. We think it might be A, but we're going to check all of them to make sure. Right. Well, net C looks similar. It's got these nice sort of shallow front and back and side pieces, but what it hasn't got is it hasn't got a lid. So it can't be that one. And then net D, well again, we've got two side bits, the front and the back, but we've got no lid. So even though they look high, with no lid, it can't be any good. So which net diagram best represents the box shown in the picture? Well, it's got to be net A. And they've said, explain a reason for your choice of net in the box below. Well, we can say, well, C and D have no lid. And we can say B, all sides are the same, which is not what is shown in the picture. Something along those lines. Part B. Devinda has received an order for 100 bracelets. She packages each bracelet into a box, 10 centimetres by 8 centimetres by 3 centimetres. So I'm going to draw the measurements on. So this is the longer side. So let's say that's the 10 centimetres. This way is probably the 8. And then the height is going to be the 3 centimetres. Okay. Devinda will put 100 boxes of bracelets into larger boxes for postage and delivery. She has a choice of box A or box B with measurements as shown below. She will only use one size of box. Box A costs 70p each and box B costs £1.80 each. She wants to spend as little as possible. So let's look at them. Here's box A. So it's bigger because it's got to fit lots of those smaller bracelet boxes into here. And here's box B. So box B looks bigger, but remember it's more expensive as well. Should Devinda choose box A or box B? Show your calculations and or workings out in the box at the top of the next page. Right, well we're going to do all of our workings out on here. What we want to work out is how many boxes are we going to need. So if we use box A, how many of these ones will we need? And then we can work out the total cost. Right, so we we've got our measurements up here, 10 by 8 by 3, and this is 50 by 8 by 12. Well, 8, if you remember ours were 8 as well. So you can kind of think of it as, let's try and make this a bit more 3D. Okay, now with ours, if they're 10 centimetres, 8, we could sort of have 10 by 8, and then 10 by 8. And because it's 50, we could fit 1, 2, 3, 4, 5 of these in here. Yeah, because they're 8 centimetres, so they're going to fit fully along the floor. And then they're 3 centimetres high. So it's like we'd have a sort of a level there. Now, this is 12 centimetres high. So if it's 3 centimetres, how many could we fit going up? Would it be 3, 6, 9, and then 12? So what we're saying is we can fit 5 boxes on the base, and we can stack them times 4 high. So in other words, 4 times 5 is 20 boxes. Right, so we can fit 20 of our small bracelet boxes into box A. Okay. Now we want 100 of them. Now 100 divided by 20, and we can use our calculator for any of these calculations. 100 divided by 20 is 5. Equals 5 of box A. Okay. So if we do 5 times 70p, it's going to be £3.50. Okay. Well, now let's work out how much it would cost if we used box B instead. Right, well, we can do something similar here. We could stack them along the bottom. Now this, again, I'm going to try and make this look a bit more 3D. There you go. So we can fit ours along here again, but this is 16 centimetres deep. So if it's 16, well, we could fit 10 by 8 and another 10 by 8. So if we split it up, we can have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 along the base. So 10 on the base. Remember, they're 3 centimetres high. This box is 15 centimetres high. So we can have 3, 6, 9, 12, 15. So that's 1, 2, 3, 4, 5 boxes. So 10 on the base times 5 boxes high. Well, 10 times 5 is going to be 50 boxes in box B. Right. Well, we want 100 of them. So if we've got 50, well, we say 100 divided by 50. You can use your calculator, but that's going to give us 2 boxes. And we can have that down here. So if that's 2 boxes, it's going to be 2 lots of £1.80, because that's what they cost. And 2 times £1.80 is £3.60. So if we use these box A's, it's going to cost £3.50. If we use box B's, it's going to cost £3.60. Okay, well, £3.50 is less than £3.60, so box A, that's the one we want. Right, let me just make sure that I've got the right page and I don't mix up the order of these. Okay, right, we're on to question 18 now. Devinda wants to know what her best-selling... So let me straighten this up. Devinda wants to know what her best-selling item of jewellery is and which jewellery items sold the most consistently over the 6-month period from July to December. She has this information. So we've got jewellery item bracelets. We haven't got how many. The mean that were sold, or the range. But for necklaces we have, and rings, and earrings. The table below shows the sales of bracelets over the 6-month period. Okay, here we go. Which is the best-selling jewellery item over the 6-month period? Show your calculations and our workings out here. Okay, well, the first thing we need to do is to work out our values for bracelets. So if we want to work out the mean, we're going to say, well, the mean is the total divided by how many? Right, so our total is going to be 23 plus 22 plus 38 plus 28 plus 44 plus 97, which gives a total of 252. And how many months were there? 1, 2, 3, 4, 5, 6. In fact, they've told us it's 6. So 252 divided by 6 gives us 42. Now the range of items, or the range is the difference between the biggest and the smallest. So the biggest That's 97. What's the smallest? 23. 22 smaller. So the range is going to be the 97 minus 22, which gives us 75. Okay, right. Now, we've worked out the mean and range. We've got all of those values in. It said, Devinda wants to know what her best-selling item of jewellery is and which jewellery item sold the most consistently. So the best-selling item is going to be the one with the highest mean. 42, 47's bigger. So it's going to be necklaces. So we can put necklaces are the best selling. And we can put mean of 47 per month. Now part B, which jewellery item sold the most consistently over the 6-month period? Well, most consistently is going to be the one with the smallest range. So in other words, the smallest difference between the most amount sold and the fewest sold. So let's have a look at these. Which one had the smallest range? 75, 85 is bigger. 62 is smaller than all of them. So it's going to be rings. So we can put rings. Range of 62. And finally, part C. Devinda makes a profit of £1,592 from jewellery sales. She wants to use a third of the profit to buy more stock and pay the remainder into a savings account. How much money will Devinda pay into the savings account? Okay. Well, what we could do is we could work out a third of this and then take it off to find the answer. I'm going to do something which is a bit of a shortcut. If she wants to use a third to buy more stock and the rest in her savings account, well, the savings account, the rest of it is going to be 2/3. Because if you've taken 1/3, you've got 2/3 left. So instead of working out a third and taking it off, I'm just going to say, well, let's just do 2/3 of 1,592. Now you can do it the other way, and you will get, if you do it right, exactly the same answer. Now, because of rounding, I'm going to type in the 1592 times 2/3, which gives me £1,061.33. In fact, I'll show you if you do the 2/3 first, we should get, we get the same answer anyway. Okay, and it's because it's money that we round it to 2 decimal places. And that's the end of the paper. So I hope you found it helpful. Please like the video, subscribe to the channel, make sure your notifications are turned on so you get updated when I load more videos. And I look forward to hearing any of your comments and questions. And I'll see you all again soon. Thank you.